So the scatter plot is a plot of paired XY quantitative data with a dot representing each pair of points. So if we have pair of points represented by XY, and this is quantitative data which we can measure, then each dot in the scatter plot will be representing one pair of point which is represented by X and Y, and this scatter plot is helpful in determining whether there is a relationship between two variables or not. So in this figure you can see an example of a scatter plot, and you can see a number of dots here, and each dot here is representing an XY pair which is represented with an X value and a Y value, and it is necessary that these XY pairs are quantitative data which can be measured. So in this way you can observe the data, and you can see that what is the pattern which our data set is following. So in this figure you can see that we have a very good pattern, so that if I solve this problem with a regression equation, this problem can very beautifully be solved with a regression line, because if I draw a regression line in this way, then it will be best fitting most of our sample points, right? So if these sample points are much more scattered in both these directions, then there was a possibility that this problem may not be solved with a simple linear regression. But now in this way this problem can be solved by linear regression. Another important graph which we use in such scenarios is a time series graph, and a time series graph for a quantitative data collected over time and plotted accordingly with the horizontal axis representing some measure of t, right? So here basically we are representing data on the basis of time. So we have a time limit here, right? So here you can see that the x-axis is representing different number of years, and we have some attributes on the y-axis. Now this data is collected over some timestamps, over some increasing number of times, and we are plotting our data on this time series graph to have an observation. So time series graph is basically representing time-based data which is collected over an increasing time stamps. So this is another graph which we use in regression analysis. Okay, so now let's see that what the outliers are and how do they affect our solution. So outlier in a scatter plot is a point which lies far away from other data points, right? So if some points are lying quite far away from the remaining data points, then we can say that these points are the outliers, right? And as I told you earlier, that the outliers can occur due to many reasons, and one of those reasons is the presence of noise. And another important point is the influential point. So influential point is a point that strongly affects the graph of the regression line, right? So if a point is having a very severe effect on the regression line, and then we can say that that point is acting as an influential point. So if we remove that point, or if we add that point, then it will have a very strong effect on our overall regression line. So here is an example. If we have 40 pair of shoe prints and height, the same example which we are considering, we observe that what happens if we include this additional data point, right? So if we add some other data points which can be some outliers or maybe some other data, then if we draw our regression line with the addition of those points, you will see that there is a very severe change in our regression line. So you can see in this figure that our regression line is changed very dramatically, right? And that was only because of addition of this influential point here. So if I add a point here, then this regression line which is occurring here will be start occurring here. So these points which have a very dramatic effect on the regression line can said to be influential points. The additional point is an influential point because the graph of the regression line did not change considerably. The additional point is also an outlier because it is far away from the other points, right? So according to the definition of an outlier, the outlier should lie far away from the remaining points, and you can see that this point is an outlier because it is placed far away from all the remaining lines, and that's why it is having a bad impact on our regression equation. Okay, so now let's define another term which is the residual term. So the residual for a pair of xy values, we can say that the difference between the observed sample value of y, which is a true observation, and the y value, which is the prediction which we are making on the basis of x value, we can say that the regression equation y hat is the residual. So residual is calculated with this equation, right? So we are defining residual as observed minus predicted, right? So we have one value which is the actual value or which is the observed value, and we are representing here with y, and then we have a predicted value, right? The prediction which we are having from our regression line or regression equation, and we are representing here it with y hat. So if we take a difference between the observed value and the predicted value, then this difference will give us the residual value. So a residual represents a type of inherent prediction error. So this subtraction will give us that how much error is present in our prediction. So it is basically a prediction error. The regression equation does not typically pass through all the observed data values that we have. So practically in most of the time it's not possible that regression equation is best fitting all the points. So there are some points which remains away from the regression line, so that can act as some a little bit of error in the prediction. The other thing is the least square property. The least square property is a straight line that satisfies this property if the sum of the squares of the residual is the smallest sum possible. So in this figure here you can see that we have different data points here, and we have a regression line. So on the basis of the difference between the predicted value and the actual or the observed value, we are calculating the residual of each point. And you will observe here that the more a data point is far away from the regression line, the more value it will have, right? So this in this way we can calculate the residual values for all the sample points.